All right, apparently I'm recording. Good. Tired and nervous for the quiz. I got 1 hour of sleep, but this was voluntary. I hope that I hope you don't do that tonight. Get only 1 hour of sleep, because especially back to back. But I'd be worried about the quiz with that little sleep, especially twice. Excellent, Crystal. Oh, good, Angel. Good, Karen. Excellent. Okay, Matt. It's all right. Should have came into the homework help. You could have got a little bit of guidance there, and maybe cut down some of the work that you were doing. Yeah, Elias, it's gonna be some work. It's gonna be some work. Nothing, Haley. Okay, no worries. Tired, Giovanni? And Giovanni, you got decaf stuff starting up here too. Some of you still haven't joined yet for some reason. Is there an issue I need to know about? Because I'm about to get started here. But you don't need the activity just yet. But I'm just curious why we have so few people. The classroom link, Alexis, I just put it in the chat right now. Um, put it here again in the chat. Oh, okay. That's my bad. Okay. Apparently, I'm sending it to everybody in the waiting room for some reason. You can chalk that one up to old people with technology issues. So I'm just pausing for another moment, letting people, the last couple people join, and then we're going to get started here. Thank you, Sophia. I'm glad it was helpful. Stephen, I do too. All right, Mia, you can get on top of it. A subtle challenge? I'm up for a subtle challenge? Interesting. A hassle, yeah. Yeah. That's funny, Cyrus, the way you put it. Homework help is going to be just about every day. The exception to that might be on days we have a test, which I'll explain more as we get closer. But we'll probably still have some sort of meeting. Well, you got to remember what I did last year for that. But yeah, we'll have homework help almost every day, if not every day. All right. So today we're gonna use the Desmos activity here more as practice after I show you something, teach you something. Um, so we'll give a little bit of theory, lecture, whatever, content, and then I'll say let's go solve a problem on the Desmos activity, and then you'll go solve the problem, and then we'll Then we'll go from there. All right, so we're going to start with the SAS formula. I'm assuming you can see what I'm writing right now. I'm sharing the correct screen. If not, let me know. For the area of a triangle. Now, you guys are all familiar with the usual 1/2 base times height for finding the area of a triangle, but that's not the only formula that we have for finding the area of a triangle. And so the SAS formula, if you guys go back and think into an earlier class, it's probably integrated too if you're on our campus, maybe a geometry class if you're from some other school. But you learned the 5 different ways of proving 2 triangles are congruent to each other. And one of those on the list is the SAS formula. The 5 different ways are the side, 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 angle, side, which is this one, angle, side, angle, 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 side, and hypotenuse, leg. Those are the 5 different ways that we prove 2 triangles are congruent to each other. Now, those 5 formulas, or those 5 different congruence properties that we have, they weren't just invented to torture young minds like yourself with this idea of proving triangles are congruent. There's actually a larger purpose to it that I like to stress that I don't think teachers stress enough when they teach students about congruence. If 2 triangles are congruent to each other, that means they are identical in every way that's mathematically significant. They have all of the same side lengths. They have all of the same angle measurements. They each have the same area. Okay, so it's uniquely described. And so the idea of using one of the congruence properties to show that 2 triangles are congruent is saying that we don't need to know that all 6 pieces are the same in order to show congruence. I just need to know 3 of the pieces, okay? All 3 of those involve 3 pieces. Even hypotenuse leg, even though it references 2 pieces, is about 3 pieces because the third piece is knowing that it's a right triangle. Knowing those specific 3 pieces are enough to show that 2 triangles are congruent. And if 2 triangles are congruent because they each have 3 sides that are the same, or they have two sides and the included angle that are the same, that means their triangles behave exactly the same way. They have all the same sides, they have all the same angles, they have the same area. That means the triangle is uniquely described by these 3 pieces of information. So there should be a way to derive the area of the triangle knowing just these 3 pieces, because we know every triangle that has 2 sides and the included angle exactly the same, they're going to have the same area. So we don't have to rely on the traditional 1/2 base times height formula. We can do this another way. So let's take a look at a triangle. And let's see if we can come up with this formula here. Okay, so let's suppose for a moment that we have this triangle right here. Okay, and I know this side is A, and I know this side is B over here. Okay, and I know this angle measure right over here, we'll call it theta, just to give it a name. Now, if I normally wanted to find the area of this triangle, we would drop the height right over here. Okay, we would label this H. And then we would go through, we would say the area is going to be, like we said, 1/2 base times height. But I want to find the area of this formula, not using the base and the height. I want to use the angle, the 2 sides over here and the included angle. I want the formula to be in terms of little a, little b, and theta instead of b and h, okay? But if I look at this picture here, and I used a little bit of trigonometry, little right triangle trig, because we have a right triangle right here, I should be able to recognize that the sine of theta is going to be opposite over hypotenuse, side h, or the height h over the hypotenuse a. And if I multiply both sides by a, I know h is going to be a times the sine of theta. And I can go plug this value in here into this formula down here for h, which tells me that the formula here can be rewritten. And I'm going to put it in a slightly different letter ordering here, the more traditional way. This is how we tend to write this formula. This is the formula for finding the area of a triangle using two sides and the included angle. This is our SAS formula. A and B are two sides of the triangle. Theta is the angle between them. And if I know those three pieces of information, I could find the area of that triangle by taking 1/2 the product of the two sides, A times B, times the sine of that included angle, times the sine of theta. So that's your SAS formula. Now I want you to use that formula on screen number 2 in our Desmos activity. So let me open up screen number 2. Now type things into the chat if you need some help or you have questions. Zoom out so you can see the top. You're welcome. Good, Giovanni. Yes, Josh. Now just calculate it. Well, you don't have to go through all those steps. I mean, you certainly are welcome to if you want to, but the purpose of the formula is to not have to go through all those steps. Good, Isabel. Good, Samaria. Good, Karen. Good, Isabel. Good, Alan. You're correct, Josh. I would like to see a numerical value for that too, just to make sure you can type it in correctly into your whatever calculating device you're using. Juan, I don't think you're done typing. If you are, that's not correct. Same for you, Ashley. It looks like you're not quite done typing. But if you think you are, then it's not correct. Just kind of waiting, just, letting people catch up a little bit. Alexis, are you still here? Did you join by chance? Were you able to join in? It isn't letting you join. Skylar, I hope everything's okay. Okay, that's weird, Alexis. I apologize for that. The sorry everyone, I got to kind of do not double work, but just I got to kind of do things a little differently until we get Alexis signed up here. The example that everyone's working on right now is to find the area of a triangle that looks like this. This is 42 degrees, and then this is 8, and this is 11. So I'll try to give you some pictures. A lot of them are pictures today, Alexis. So um, I'll give you a moment to work that out, then I'll get started. Good Monique, good Haley, good Elizabeth, good Noel. That's correct, Ashley. Make sure you have, well, there's no way to put the degree symbol in that I'm aware of, but make sure you know that you're 42 degrees and that you can type that in properly into the calculator. Good David, good Edson, good Argentina, good Alan. Ariana, I disagree with your number. Good Angel, good Sophia, good Valeria, good Elias, good Stephen, good Juliana. All right, so let me work this one out. All right, so as the formula says, we're just going to take the two sides, A and B, that are adjacent to each other, and then multiply them together, multiply them times a half, and then multiply by the sine of the angle 42 degrees. So for this one here, the area is going to be 1/2 times 11 times 8 times the sine of 42 degrees. And then if you run that through a calculator, you should get about 29.4417. I hope that makes sense. I didn't create a lot of examples for this one here because it's just a formula that's pretty straightforward. So we can add into the next question with the next topic more practice with this if you guys want. Uh, you always have to be adamant about your education. If what I'm doing requires you to see more examples, or if I'm not doing enough examples for you, then you should speak up and tell me. Otherwise, I just keep going, which is not necessarily what's best for you. Like I said, I'm going to keep going to the next topic, which is related, and we can practice this a little bit more if anybody cares to in a minute. As mentioned in the homework, whenever a problem says solve this triangle, you're going to be looking for any missing angles or sides. And we have a couple specific tools that we use to solve triangles. I mean, you guys are familiar with some already, like the Pythagorean theorem that came up with within the homework, and then using trig ratios in a right triangle to solve. But we can use trig ratios in other contexts as well. We have something called the law of sines that I hope you have seen before. You should have at some point. It's usually not, pre-calculus is not the first time the law of sines is introduced. So in a triangle, it doesn't have to be a right triangle. Actually, I'm going to make it a little different. I don't want it to look so equilateral. In a triangle, if I have sides P, Q, and R, and then I'm going to use a typical naming convention. The opposite side is going to be the lowercase version of that letter. So vertex R is here. The opposite side is going to be lowercase r. This is a capital P. This is a lowercase p, capital Q, lowercase q. Okay. The law of sines says that the sine of an angle, the sine of angle P divided by its opposite side, lowercase p, is a constant in any triangle. So that means if I take the sine of a different angle, sine of angle Q, and divide it by its opposite side, Q, then I have to get the same amount. That's the same value. That ratio is exactly the same. Also, if I do that for the last angle as well, the sine of angle R divided by side length R is exactly the same. Now, this is a nice feature. In mathematics and physics, all the time we're looking for things that don't change in certain situations. If I can find a quantity that doesn't change, then I know I could use that quantity to solve for other quantities. And so knowing that the ratio of the sine of an angle divided by its opposite side in any triangle is a constant allows me to then use that fact to solve for missing pieces. Now, we could rewrite this by flipping all the fractions over. There's nothing wrong with this. It is mathematically equivalent. So if I put P over sine of P, the side P divided by the sine of angle P, that's going to be equal to Q divided by the sine of angle Q, or side length R divided by the sine of capital R. So either way, for the law of sines, this is true. Either way you want to write the ratios, those are true. Now we should try to prove, at least in one case here, why this is true, so you can understand why, and not just take this on faith. This is not a religion class, ladies and gentlemen. I don't want you to believe everything I'm telling you just because I said it. I want you to understand it, and I want to give you some justification for it. So let's put in a height right here, and we will try to show at least a pair of these ratios are the same. So if I look at the small right triangle on the left here between vertices PQ and this new side, the height H, I can set up a ratio here. The sine of angle P is going to be H divided by R. H is the opposite side, R is the hypotenuse. Now, if I use the longer triangle over here on the right, I can do something similar with the sine of angle R. The opposite is going to be H, and now the hypotenuse is going to be side P. I could solve each of these equations for H because they both have H in them. So if I multiply both sides by R over here, I get H is equal to R times the sine of P. And then over here, if I multiply both sides by lowercase p, I get H is equal to lowercase p times the sine of R. And now since both H's are the same, see, H is this length here. So it's whatever value it is in this equation, it's the same value in this equation. So I could set them equal to each other. R times the sine of P is going to be P times the sine of R. And now I can just solve. I can divide both sides by R. And I can divide both sides by P as well. The R's will cancel, the P's will cancel, And I'll end up with the sine of angle P divided by side length P is equal to the sine of angle R divided by side length R, which is, from our first equation that I wrote up here, those two things are equal to each other. We could do something similar with side Q. I would just have to use a different height, okay? And I'm not going to take the time to do it because the argument's exactly the same. I would just have to draw in a height from, say, P over to this side over here, that's where the height is, use this different H, and then set up two sine ratios, solve for H in each of those, set them equal to each other, and then rewrite it. It's a trivial exercise I'm not going to go through the steps for. This is the law of sines, and we can use this to solve certain types of triangles, okay? So we're going to go back to the Desmos activity. We're going to go to screen number 3, and we're going to solve that triangle. For those who can't access the activity right now, I'll sketch a picture so you can see it. But everyone else who can, please go to screen number 3. So you're finding all the missing angles and sides. Well, it's only one missing angle, but two missing sides. If you're absolutely stuck and maybe need a hint or something, you can ask. But right now, I'm just trying to be patient and let people solve. If you're stuck, start by trying to find the missing angle measure. Oh, sorry, Isabel, I just noticed yours, your comment. I saw somebody else make a comment. So we know that the angles in a triangle should add up to a certain amount. So that means you can find the missing angle first. Good, Samuel. Angel, I like most of your work, or some of your work. You're close, Angel, but you're off a little bit. Your value for AC is a little small, and your value for AB is a little big. Karen, yours looks good to go. Sophia, your sides are good. You just need the angle measure, which I'm sure you have somewhere. You just need to type it in. David, you're good to go. Ashley, you're good to go. Haley, you got the first two things you've answered correct. Giovanni, you're good to go. Now, ladies and gentlemen, as we give decimal approximations, there's no standard for this at the pre-calculus level, so I'm going to sort of create a standard for you. Try to go to 3 decimal places in your approximations unless the problem says otherwise. And the reason why I'm asking for that is in calculus, we most of the time have to go to 3 decimal places on the AP exam. That's the standard that they want from their calculus students, unless the problem says otherwise, and sometimes it does. And so let's start building the habit now to go to 3 correct decimal places. That way, it just becomes a natural thing. When you move on to calculus, you're ready to handle, or that becomes just the habit that you do, and you don't have to think about it anymore. Ashley, I told you yours was good. You still have your question mark there. Well, you're good, except you first need the angle measure, but you probably have that somewhere. Monique, I would imagine you might be in the wrong mode on your calculator, looking at your number. All right, let me give some support on this one, and then we'll do the next. All right, so the sum of the interior angles of a triangle is 180 degrees. And so to find the measure of angle A, we're going to subtract from 180 the 77 and the 28. And when you do that, you should get 75 degrees. And so you found your missing angle. And now we just got to find the missing sides. And so to find the missing sides, we're going to use the law of sines here. So we'll take the sine of, now we know this is, I'm going to add this into the picture. This is 75 degrees. So the sine of 75 degrees divided by its opposite side, which is 12, is a constant for this triangle. And it's true for the ratio of the sines of the other angles and their opposite sides. So the sine of the 28 degrees divided by, I'll call this lowercase c to follow the convention described earlier. So this ratio has to be the same as the sine of 28 degrees over c. And I can solve for c. If you cross multiply, you're going to get c times the sine of 75 degrees is equal to 12 times the sine of 28 degrees. I'm showing more steps than I would care to, but just to make sure everybody's not getting lost yet, or at least by the algebra. And then you got to go run that through a calculator, making sure you're in degree mode, and then you get 5.832. Actually, let me see if that, yeah, 32 as the value of side length C. And then to find the side length lowercase b, the sine of 75 degrees over 12 is going to have to be equal to the sine of 77 degrees over lowercase b. Now I'm going to shortcut the mathematics here. So this becomes b is going to be 12 times the sine of 77 degrees divided by the sine of 75 degrees. And if you run that through a calculator, you should get a little bit more than 12.104. I think it's 4.1. I don't know, I can't read my own writing. So, no, it's a 9. So you can round this to a 5. And on the calculus exam, you could either truncate or round. So let's do some rounding here. Let's make this a 5, because you guys are more used to that for the moment. We are going to do one more like that, Elias. I do have one more set up in the next slide or next screen for Desmos. So yes, absolutely. I do want to make a comment though before moving on. Ladies and gentlemen, it would be wise for you to develop a habit of ensuring that your answers are reasonable as best you can based on the context of the problem. So for example, if you're looking at the relationship between angles and sides of a triangle, the largest angle in a triangle is going to be opposite the longest side. So B should be the largest value between the 12 and the C. And it is. 12.105 is bigger than 12 and bigger than the 5.83. And if I didn't have that, if that wasn't true, if my answer for B came out smaller than 12, let's say, then I would know right away that my answer is incorrect, because B is opposite the largest angle of the triangle, and so it has to be the longest side. And so what, just those little habits like that of checking to make sure that you're doing something or your answer is reasonable for the context of the problem, as I said, as best you can. Sometimes it's a little bit hard to tell that it is reasonable. But just to take a moment and look and say, are my answers reasonable? It's a good habit to get yourself into, because sometimes you're going to catch mistakes that you wouldn't otherwise catch if you didn't take a moment to take a look. Continuing with that line of thought, the 28 degrees is the smallest angle, so C has to be the smallest side. And again, it is. That doesn't mean we're right, but at least we know we're not definitely wrong. If C would have come out to be bigger than either of the other two sides, we would be wrong for sure. But since C is the smallest, angle C is the smallest angle, side C is the smallest side, we at least have the chance of being correct. All right, let me open up the next screen. So you can try this again. And I'll draw this for those who can't see it. I think we're on screen 4, right? Yeah, screen 4. And we got ABC, 36 degrees here, 112 degrees here, and this side length is 11. Solve the triangle. Cyrus, uh, I'm trying to figure out the best way to answer the question. What you want to do, um, you don't want to have direction all the time when trying to solve a problem. What do I mean by that? You want to think independently. You want to do as best you can to think through the problem with the tools that you understand mathematically to solve it. If you can find a different way to solve the problem other than the most recent tool that I've given you, and it's correct mathematically, by all means, go ahead and use it. Okay. Um, with that said, I just taught you something, and the likelihood of us using that thing is pretty high. I hope that made some sense. right. Just gonna start at the top. Good, Giovanni. Good, Juan. Haley, you got 2 of the 3 things. I'm sure you're almost to the other. Same for you, Alessandro. Noel, you got the 2 sides, so you're pretty good to go. Good, Samuel. Try to go to 3 decimal places for, right now, Samuel, as I was saying a little while ago. Good, Edson. Good, Argentina. Good, Alan. Ariana, your angle's correct. Your sides are a little bit off. Close. They're in the ballpark, but they're just a little bit off. Isabel, you're good to go. Gabriel, you're good. Karen, you're good. Sophia, you're good. Valeria, good. Juliana, how did you get the degree symbol? I don't even know how to get that. You gotta teach me. Oh, it's a Mac thing. Ah, cheater. No, I'm just kidding. I can't give you as much attitude yet as I give your sister. She knows me better. Eventually I will, though. Be ready for it. Start by finding the missing angle if you're stuck. Josh, your 2 side lengths are good. I'd like to see the angle measure. Just, I'm sure you have it. Otherwise, you wouldn't have both sides. But just to include it would be helpful. Thank you. It is part of the problem. It does say to solve the triangle. So solve, you have to, state all the missing sides and angles. Matt, did my response not help your question? I know some of you are just waiting for me to continue, so let me continue. So similarly, we're going to find the measure of angle C using our triangle sum theorem. So subtract the 112 and 36 from 180. You should get 32 if your arithmetic is like mine. And then we can use our law of sines to set up some ratios that we can use to solve for our missing sides. So sine of 112 degrees over 11 has to be the same as the sine of 36 degrees over its opposite side, which I'll call A, lowercase a, which most of you did, if not all. And then if you do your cross multiplying and solving, you're going to get A is equal to 11 times the sine of 36 degrees over the sine of 112 degrees. And then you get a number for that. I don't remember. It's 6 point something. I'll go look at it in a moment. They're both 6 point something. I think it's 6.97, I think, but I'll double check that in a minute and write it down for you in a moment. The sine of 112 over 11 is also going to be equal to the sine of 32 degrees over side length C. And then when you solve for side length C, you're going to get 11 times the sine of 32 degrees over the sine of 112 degrees. And then we'll run that through. That's, again, 6.2, I think. But I'll go double check those and then I'll get back to you. Actually get the number 6.286. So 2.287 with rounding. And then the other is 6.973. Somebody have a question?
I don't know. Thank you. Thank you too.
All
And so
right.
she was like,
Skyla, could you mute yourself, please?
oh, sure.
Thank you. I opened up screen number 5. Go and take a look.
Mr. Francis,
Yes.
I was wondering how you got those because my answers were really close, but when I multiplied them, they were not the same. Like for the 11 times sine 32 divided by sine 112, I got 6.232. And I was wondering if I did anything wrong with the multiplication or
What device are you using to multiply?
a TI 30X 2S, I think.
And you're in degree mode.
Yes.
And so you typed in 11 times sine of 32, and then you closed parentheses on the sine of 32, and then hit the division button, and then did sine of 112.
Oh, that's why. Okay, my bad.
All right. Glad
Sorry.
you asked, though. Yeah, no, don't apologize, please. Ladies and gentlemen, if you're not getting the answers, it could be something like the way you're typing it into a calculator. It could be some other misunderstanding. You have to speak up, as I mentioned yesterday, and I'll keep trying to remind you of this. If you don't communicate with me, I can't help you. So if you have a question because you're not getting right answers, you got to let me know. I'll try to troubleshoot with you. I hope I'll be able to find the problem. I was able to help Matt out right there, and I appreciate him being willing to ask, because he now fixed his mistake that he was the way he was typing it in, and now he was going to get correct answers. And on a future quiz, I want him to get correct answers because he's demonstrating understanding, not because he has a typo in the calculator. Okay. And so that's the same thing for all of you. If you're struggling to get my answers, then you need to speak up and ask. So great job, Matt, for demonstrating that for the rest of the class.
You're welcome.
Now, Monique, make sure you put the angle measure down too. So I'm mentioning that to some of you. You can't get these values without finding the angle measure. But if I give you a quiz and it says solve this triangle, and you don't give me all of the missing pieces, all the missing angles, all the missing sides as part of your answer, then your answer is incomplete and you cannot receive full credit. So it's not me being critical right now and wagging my finger at you. I'm trying to train you, if you will accept that phrase, to give correct answers to the way the question is being asked. Okay, so it's, again, I'm not being critical in a negative way. I'm just saying, if you want full credit on a future assessment, when it says solve the triangle, you have to make sure you list all of these things in order to be able to get that full credit. So some of you are listing only the sides, but you got to list the angle as well. So Elias, you must be on a Mac also, because you're using the degree symbol there as well. I kind of like that, Cyrus, using the star as the in place of the degree symbol. Kind of like that. It's a creative use of that. It's another alt thing. What do you mean? How do you? Okay, teach it to me, Elias, please, because I want to learn too. Alt what? Alt 0176. How did you learn this? You can't just randomly try these 4 digits like that. You Googled it. Excellent. You know, I like it. I'm just gonna say I like it. So those of you using, oh, Josh used looks like the letter O as an exponent. That's a little clever use of it, but Alt 0176 is what Elias is sharing to get the degree symbol on a PC or probably a Chromebook too. I like it. There was another question. Argentina, I'm going to be purposefully vague at the moment for slide 5. You use whatever is allowable mathematically. I don't see a lot of stuff happening yet on screen 5. Is there an issue? Now, Ariana, I didn't ask for the area, although this is a perfect question to practice that concept. So I'm glad you are reminding me on that one, for that one. But just as a side note, ladies and gentlemen, I didn't ask for the area, but you certainly are welcome to practice our SAS formula that I gave you at the start of the lecture today. In place of as something else to practice. That's a great question, Mia, and I'm being a bit vague at the moment. I'm actually wanting to see who is familiar with solving this one here. I see one student is, he's doing well. Oh, I forgot to draw it for those who are not able to see the screen at the moment. My apologies. What if you have two angles of the same measure, but their opposing sides are not exactly the same value in length? They have, if there's something called the isosceles triangle theorem. An isosceles triangle has two equal angles, and the isosceles triangle theorem says that if you have two equal angles, then you have, actually, I'm sorry, it's the reverse. I'm giving you the converse of it. But if you have two equal sides, then you're going to have two equal angles. The angles opposite the sides have to be the same. So it would not be possible to have the angles be two angles be the same measure, but their sides not be exactly the same. They have to be the same. We could prove it. You probably did back in an earlier class. Probably integrated 2 in our district, geometry and others. Are we stuck, ladies and gentlemen? That's okay, good. A little bit, yes, yep, good. You're gonna be stuck at times. It's just part of what's going on. Okay, thank you for all the feedback, ladies and gentlemen. I intended for you, mayhaps? Did you mean perhaps? I intended for you to be stuck on this problem here. So it looks like a couple people might be working their way through it. Almost the same. So they got to be, there should be maybe a rounding difference in the angles then too, or something like that. The tool of the law of sines is not sufficient for this problem here on screen 5. Yes, it's no, actually not on this particular example, Argentina. I don't think so, unless my mind is not firing well at the moment. But let's get into another concept, and then we'll apply it to this particular triangle here. So I'm going to go away from this triangle in particular for just a moment. Actually, no, I'm not. Real quick, before I do that, if I try to set up the law of sines for this, and let's call this lowercase a right here, and say the sine of 52 degrees over lowercase a is going to be equal to the sine of angle B over 11. The problem here is I have one equation, but I have two unknowns in that equation, side length A and angle B. And I can't solve an equation where if I have just one equation with two unknowns, I can't solve that for a unique set of values. And so the law of sines is proving to be insufficient in this example. Okay, well, we're gonna have to learn a new law. We have a law of cosines. And I see a couple of you remember it, are using it. If you've learned it before and now I've triggered it for you, like, oh yeah, now I know what to do, go for it. Go ahead and do it. But I'm going to set up the law of cosines here, and then we'll prove it, and then we'll go back to solving it. I'm actually looking at the clock for a moment. Do we need a 15-minute break? Probably should have a 15-minute break and then come back and continue this. That's what I'm thinking. Let us all run to the restroom, especially those of us who've been here since 8 o'clock. It's been more than 2 hours. It's 10:10. Let's take a break to 10:25. So 15 minutes. Whatever your watch says, add 15 minutes to that. Come back then, and then we'll continue. Go take a break, ladies and gentlemen.